Okay, good Thursday, sixth graders. If you are following along with my lesson plans that were posted at the beginning of the week, today we're going to read and highlight section 3.5 over metamorphic rocks. That's only pages 114 to 117. This is the video that I'm adding now. If you don't like the sound of my voice, you can always log on to the Savvis site and listen to that other girl read it to you. Maybe another chapter will get the man's voice, which I always thought was pretty interesting. So we're going to start on page 114, reading Metamorphic Rock. I am going to assign for you to answer these questions, and then we will go over them tomorrow. So if we think about, if we kind of do a quick review of our geology unit, we started with metamorphic rock. We started with minerals, and then we went to rocks and how they're classified, and we studied igneous rocks, and we studied sedimentary rocks, and now we're reading about metamorphic rocks, and your focus is just what are metamorphic rocks. But if I asked you, what did we use metamorphic rocks for? I think that most of you would know the two words that I'm looking for. So let's get started. My Planet Diary, a common misconception. Let's see what it says. Rock dough. Rocks do not change form. But remember, that's a misconception here. Did you know that heat can change a rock's form without actually melting it? To understand how, think of what happens when you bake cookies. You mix flour, egg, sugar, and baking powder in a bowl. When you bake the raw dough in a hot oven, the dough changes into cookies. Heat can change rock, too. If hot magma or lava come near rock, the heat can bake the rock. The ingredients in the rock, the minerals, might not melt, but the heat can still change the rock into a new form. So it asks you over here, does rock have to melt in order to change form? And it seems like we answered that right here at the end, so you know you're going to write no, and then, but it does ask you to make an explanation. I'm going to see if I can pull really carefully over our sedimentary rock jar and slightly turn it on its side. It's starting to get clear up here. We still have plant matter and some very light soil that floating at the top. But you can see how some of this white stuff is trickled down. Remember when we talked in sedimentary rocks about that then cementing together. So if we were near a pocket of magma, this rock might kind of bake. So let's put that up there and kind of review that when we review them all. So what are metamorphic rocks? You may be surprised to learn that heat can change rock like hot oven changes raw cookie dough. But deep inside Earth, both heat and pressure are much greater than at Earth's surface. When great heat and pressure are applied to rock, the rock can change both its shape and composition. Remember, here's a key idea, so you kind of want to make that jump out for you. Any rock that forms from another rock as a result of changes in heat or pressure, or both heat and pressure, is a metamorphic rock. And maybe we can remember some of the things that I said before, that you see this little P and H at the end of that name, and that could maybe remind you of the two words pressure and heat. So let's see how metamorphic rocks form. Metamorphic rock can form out of igneous, sedimentary, or even other metamorphic rock. Many metamorphic rocks are found in mountains or near large masses of igneous rock. Now, I think I would kind of put this, I'd put a little star by it maybe. That seems kind of like where most rocks are found. It's one of those kind of superlative ideas. So why are metamorphic rocks commonly found in these locations? The answer lies inside Earth. The heat that can change a rock into metamorphic rock can come from pockets of magma, sort of like the oven. For instance, pockets of magma can rise through the crust. The high temperatures of these pockets can change rock into metamorphic rock. Now, I highlighted this because it says collisions between Earth's plates can also push rock down toward the heat of the mantle. So remember when we talked about the crust of the earth is like graham crackers sitting on a plate of chocolate pudding, and it's kind of like moving around and spinning, and those graham crackers can move around. So sometimes one graham cracker can get pushed under the other. Very high pressure can also change rock into metamorphic rock. For instance, plate collisions can cause great pressure to be applied to rocks while mountains are being formed. The pressure can deform or change a physical shape of the rock, as shown in Figure 1. So let's kind of go down here to Figure 1 and say, look at like these rocks, those layers were probably laid down in a sedimentary deposition kind of thing, and then because of this extreme pressure of two rock plates being pushed together, these ones were bent. Also, the deeper the rock is buried in the crust, the greater the pressure on the rock. Well, that kind of makes sense, right? When you are at the bottom of the pile, you kind of get smushed a lot. Under very high temperature or pressure or both, the minerals in a rock can be changed actually into other minerals. At the same time, so let's see what changes. The appearance, texture, and crystal structure of the minerals in the rock change. Eventually it becomes a metamorphic rock. Now go over here, there's a pencil. It asks you to develop a hypothesis. I'd like you to write the answer there. Almost finished. Look at right here's the end. So how metamorphic rocks are classified. So let's take a moment here and see if we can recall igneous rocks. There are two different kinds, inside the earth and outside the earth. Hopefully you remember that they're called tick, 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 intrusive and extrusive. When you get into sedimentary, we have three types of sedimentary rock. Let's see if you can name them. Tick, tick, tick. We have organic, chemical, and clastic. So now we're going to learn the two types of metamorphic rock. While metamorphic rocks are forming, intense heat changes the size and shape of the grains or mineral crystals in the rock. Extreme pressure squeezes rock so that the mineral grains may line up flat and in parallel layers. So geologists, here's that key idea, geologists classify metamorphic rocks according to the arrangement of the grains in their rocks. So we have foliated metamorphic rocks that have their grains arranged in parallel layers or bands are said to be foliated. So foliated describes the thin, flat layering found in most of the metamorphic rocks. For instance, the crystals in granite can be flattened to create the foliated texture of, this is pronounced gneiss or gneiss. Slate is also a common foliated rock. Heat and pressure change sedimentary rock into the sedimentary rock shale into slate. Now you are not familiar with slate, but a long time ago we used to use those for roofing tiles. Slate is basically a denser, more compact version of shale, but as shale changes into slate, the mineral composition of shale can change. And then of course we have, let me highlight foliated rocks and then non-foliated rocks. Some metamorphic rocks are non-foliated. The mineral grains in these rocks are arranged randomly. Marble and quartzite are metamorphic rocks that have non-foliated texture. Quartzite forms out of quartz sandstone. The weakly cemented quartz particles in the sandstone recrystallize to form quartzite, which is extremely hard. Quartzite looks a little smoother than sandstone as shown in Figure 2. So here's Figure 2. Here are some of the types of rocks that they're talking about. Finally, marble usually forms when limestone is subjected to heat and pressure deep beneath the Earth's surface. So I'd like you to kind of classify, label each rock as sedimentary or igneous, indicate whether the rocks are metamorphic rocks or foliated, then shade the correct arrowhead just the arrowhead. So you would be asking yourself, does sandstone form into quartzite? So then you would color this one. If quartzite turns into sandstone, you would color it going this way. Okay, so this one's a little bit different. So how are metamorphic rocks used? Remember when I showed you that at the beginning, the Leaning Tower of Pisa, and here it is in our book, and how much do you think it leans by this photograph? Marble and slate are two of the most useful metamorphic rocks. Once again, marble has an even grain, so it could be cut into thin slabs or carved into many shapes. So that's probably why we have a lot of statues. But marble and slate are the two most useful. It's one of those superlative things that I'm like, okay, maybe I want to know that. And marble is easy to polish, so architects and sculptors use marble for many statues and buildings, such as the Tower of Pisa. Like marble, slate comes in many colors, including gray, red, and purple. Because it is foliated, slate splits easily into flat pieces. Remember, this process here we call cleavage rather than fracture. These pieces can be used for roofing, outdoor walkways, and as trim for stone buildings. So this is a key idea. Let's highlight that. The metamorphic rocks, marble, and slate are important materials for building and sculpture. So maybe not tools, we're going to say sculpture here. So I'm going to stop there. You're going to finish and answer the questions. Tomorrow we'll go over those questions. We will do a very short metamorphic lab, and then I will give you the notes to add to your folder. So have a good Thursday, 6th graders. I'm thinking about setting up some Google Meets for us so that we can lay eyes on each other. Have a good Thursday.